Hello everyone, welcome to this video. In this video, we'll be solving another question which states that which of the following binary operations they are associative, right? So the first part here gives us the operation multiplication modulo n, right? So let's start with the solution here. Our first operation is multiplication mod n. Now, can you think of this? Is this an associative operator, binary operation? Yes, it is. So, yes, it is associative. Why? Because you can very clearly see if you take any three numbers, say x, y and z, if you multiply x and y first and then z, right, this is equal to if you multiply y and z first and then x to it, right, it would just be x, y, z, and then you can take its mod. It would come out to be some r, which is the remainder here, right? Let me call that by r of mod n, right? So therefore it is associative in nature. The second point, it tells us that we need to check whether division of non-zero rationals, is it associative? So let me write down the operation division of non-zero rational, right? So the question is it associative? So the answer is it is not associative, right? You'll see in a moment why this is so. Can you think of it? This is not associative. Why that is so? Because let us assume, let 1 by 2, right, sorry, let us consider three numbers. Let us take 1, 2 and 5 from the set of non-zero rationals. Obviously they are non-zero numbers and they are moreover rational numbers, right? Then if you divide them, if you divide 1 by 2 first and then with 5, you would have the answer as 1 by 10. And if you divide 1 with 2 by 5, so that means you are first dividing 2 by 5 and then you are dividing it by 1, it would just be equal to 5 by 2, right? So therefore in this case you can clearly see we have 1 by 10 not equal to 5 by 2. Therefore this is not associative, right? The third is function composition of polynomials with real coefficients. So the third one is function composition of polynomials with real coefficients, right? So let's consider three such polynomials. Let me call the first one as, so the answer is it is associative, right? How this is so? Let's have a look. Let's consider three such polynomials. First one, let's call it by summation aixi, where this I varies from 0 to m, say, right? Let's consider the second one, g of x. Let's call it by the index I, it varies from 0 to n, say it is bi x raised to power I. And let's call the third one as hx, where the summation in this case, it varies from 0 to p, say, right? The coefficients are ci x to the power I. Now let's first of all calculate what is GOH, right? So let's consider what is this. So we first of all apply h onto x, so that means this whole of this thing, and then we'll apply g onto this, so that means in place of x here we'll write whole of this thing, so that we would have summation I varies from 0 to n bi, right? Instead of x we are now going to write this whole expression, so it would be summation I varying from 0 to p ci. And now here, because we have already used the index I, so we cannot use I here, we have to use some other. Let's call that some other as j, right? So this is there. So we have this whole thing raised to power I, right? Next let's calculate FOG of x first. FOG of x first. So again, in the expression for f of x, we have to, in place of x, we have to write this g of x whole. So it would be summation I varying from 0 to m ai. Instead of x, we have to write the expression for this g of x, right? So here also we are changing the index. So this is what we have. Now we wanted to check what thing? We wanted to check is FOGOH of x, is this equal to FOGOH of x or not, right? To check whether they are equal or not. So for that, we first of all calculate what is FOGOH of x, right? So we first of all calculate this thing. Now in the expression for f of x, we have to substitute the value of g of x here. So our f of x is this one, right? Here in place of x, we have to substitute this value, this complete value. So let's do that. We'll change the index here. So we would have this as summation I varying from 0 to m, right? ai, and whatever is the value of x we'll write here, and let's take its power as I. Now we have to substitute what is the value of gox here. Now you already know what is gox. It is summation bi summation cj xj. So we have to change the subscript here. So it would be summation, say j varying from 0 to n bi, and whatever is the value here, we'll take this index as j. Again, within the brackets, we would have the value of k from 0 to p ck x to the power k. So this is what we would have as FOGOH. Now we wanted to calculate FOGOH of x. So that means within this expression, we have to write the value of x as that of h, right? And what was h? H was this thing. So let's do that. So we write summation I varying from 0 to m ai, right? This whole thing, summation j varying from 0 to n bj. Now instead of x, we have to write what? The value of h, which is this one. So here we would have j, here we would have I. And what is the value of h? It is k varying from 0 to p, right? ck x to the power kb. We can change this index by ourselves because we already have used the index I and the index j, correct? So you see both of them, they are equal to each other, hence the operation is associative. For the last one, for the dth part, what do we wanted to check? Multiplication of 2 cross 2 matrices with integer entries. So we know multiplication of 2 cross 2 matrices with integer entries, that is associative. So therefore this option is also correct. So we have option D, option C and option A as the correct option. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.